The proximal and distal convoluted tubules, loop of Henle, and the collecting duct of a nephron. In the proximal and distal convoluted tubules, there is reabsorption of glucose, amino acids, sodium, calcium, phosphate, and many other things. The body also secretes hydrogen ions into the proximal convoluted tubule if the body is too acidic. This is because the body needs to get rid of acid so as to maintain homeostasis. If the body is too basic, then hydrogen secretion slows down. The next part that we will talk about is the loop of Henle. It has the function of concentrating salt in the medulla of the kidney. It does this because the descending loop is permeable to water. This means that the water moves out and is carried away by the vasa recta, which are the capillaries surrounding the tubules. The descending loop is also permeable to salt, which means that salt gradually moves into the loop of Henle. However, the ascending loop is permeable to water, which means that water can't move in. Thus, the salt is transported out of the loop of Henle into the medulla. This occurs due to the concentration of salt in the medulla, which is higher and thus draws out the salt because of the concentration gradient. In the collecting duct, we have two different possibilities that can occur. One is that ADH hormone is released, and the other is that aldosterone is released. If ADH is released, it opens tiny pores in the collecting duct which allow water to be conserved if you are dehydrated. If you are too hydrated, ADH is not secreted and you get dilute urine because of the high water content. If aldosterone is released, it turns on active transport salt pumps. If this occurs, you absorb salt from the tubule into your system. See, the body always needs to maintain homeostasis. If you are hydrated, it means that you have more water than salt. The body adjusts that ratio by reabsorbing salt and by losing water. In other words, the body doesn't release ADH but does release aldosterone. However, if you are dehydrated, the body releases ADH but not aldosterone.